Vectors. So today we are going to introduce the vectors. So vector is one of the quantity that have both magnitude and what? And direction. It has both magnitude and direction. Why scalars? Scalars only have what? Magnitude but no direction. So let's say scalars. Scalars are quantities that have what? Only magnitude but no direction. Example, we have volume, we have mass, we have speed, we have what? We have temperature as well. So these are some scalars quantities, and therefore vectors quantities. We have a vectors quantity. Vectors quantities are what? There are the quantity that has magnitude and what? And direction. If we take velocity, acceleration, linear momentum, and we have what? Electric field intensity. So those are the quantities of what? Those are the vectors quantities. So you have to take note that if I said vector, what did I mean? Let's say I have V. The direction this, it is showing that this is a vector. Let's say I have AI plus what? Plus BG plus what? Plus CK. So this is a vector. This is showing what? The direction of what? Of this V. So as I write this I, J and what? And K, so this is indicating like this is what? This is a vector. This is a vector quantity because it has magnitude and what? And direction. So suppose I have what? Determine the line segment. Let's say we are to determine the line segment V1 and what? V1 and V2, and this is representing what? Vectors. So this is representing what? It's representing vectors. For instance, let's say I have V1 and I have what? And I have V2. So at this point, wherever this V1, V2, the V1, V2 vector, the magnitude of this vector are the length B1 and what? And V2, which is V1 and what? And V2. What I mean is that the magnitude of this B1 what? V1, V2 vector is what? Is the length V1 and what? V1 and V2, and whose the direction of this is from what? Is from B1 to V2. And you have to notice that the V1, V2 are what? Are called the end point. The end point of what? The end point of the vector V1 and what? V1 and V2. Let's say I have what? Let's say V1 and what? V2, vector V1 and vector V2, or what? Or let's say V1 and what? V1 and only what? And only V2. At this point, where the vector V1 and V2 are called the component of what? Are called the component of this vector V. At the end, the component of this vector V should now be equals to what? V1, V2, vector what? Vector V1 and what? And V2. So as you can see, I represent this vector in 2 dimensions, whereby I represent vector in what? In 1 dimension, and from what I explained here, because I said this V1 and V2 is representing vector in what? In this form, whereby I write V1 and what? The direction of V1 and the direction of what? Of V2. Again, if I am to represent vector in 3 dimensions, so first I have V1, V2, or let me say is V3, or V1, V2, and what? V3, all these are the components of what are the component of this vector. So the component of this vector should now be equals to, I'll say the v, which is the same thing as what, v1, v2, and what, and v3. So this is all I have for you for this introduction to vector, the definition of what vector and the scalars, and how you can represent vector, and how you can represent vector in 1 dimension, 2 dimension, and 3 dimension. Whenever you see something like this, so as you watch this, this is what, this is a vector. And whenever you're going to represent vector in 1 dimension, it's the same thing as what, v1 and what, and v2. And how you can represent vector in 2 dimension, and this is how you can represent vector in 3 dimension. And this is the general form of what vector. Whenever you see this I, j, and what, and k, and you see this direction, whenever you see a and with this direction, so it is what, so this is vector. It is showing you that it has what, it has direction. So this is all for the introduction to vector. Don't forget to subscribe to this YouTube channel. Thanks you for watching.